Hello guys, here I am again, and in a sequence of videos about DOE, now we will talk about the quantitative analysis of our results, okay, of our DOE. We had everything good in our practical analysis, no special causes, no trends, no need for transformation, data transformation. We understood what happened in our sorted estimates. We know what are the hypotheses that were validated or not, and now we are in the moment that for me is the best moment when we play with our equation, right? Our y being a function of some x, some degrees of freedom. So let's start with this fractional factorial non-replicated DOE fit model. We will have our y here and all the 15 degrees of freedom here. And now we will talk about this prediction expression. So before running a reduced model with only what is the important for us, we can use this prediction profiler and start understanding some behaviors, understanding some things that could change in our process when we change our parameters, okay? So the prediction profiler is in this form right now. I don't like this particularly. I always change this because I have 8 different factors here and 2 levels, 2 floors here, let's say. So I change the appearance, I arrange in rows, I put more than 8, for example, 10 here, and you will have all the columns in the same line. I will not talk about this desirability function yet, but I swear, I promise you, it's gonna be a video specific for that. And now we have all the prediction expression behind of this equation here. So what is it mean? That it means that you can understand the behavior in your response variable when you change some factor from the level minus to level plus, for example. Look what's happening here. In this equation here, we are putting 0 for all other factors here and -1 where you can see the letter A. So every single letter A is being changed for -1 while all the rest is 0. So you will have a value about 106.5. When you change from minus to +1, you will have 112.5. So the effect of the factor A in our response variable is 6 units. If you are measuring temperature, is 6 degrees. If you are measuring in millimeters, it's 6 millimeters. So the coefficient in this equation for the factor A is 3. This number 3 was here as well. So all the values here are the coefficient of this equation, and the coefficient here is how inclinated the angulation of this line. Okay, so more angle you have here, the bigger is the coefficient, the bigger is the effect on your result. So this is very nice, and you can work, you can play here, you can put some different situations here and see what is expected in your result when you put these values in this equation, because All here is based on your data collected in your process or in your lab or whatever. This is for a fractional factorial non-replicated DOE. Let's see the differences when we talk about a full and replicated DOE. So let's run it again. Fit module, full factorial, the y here, and see what is happening right now. The result is different because this DOE is replicated. You have this graph. This is a very, very important graph. It's giving you an idea of how good is your equation, okay? Here is the place that we will use to run a reduced model. This is the residual analysis of your results. And here your prediction profiler is different. Why is it different? Because you have, again, replicates. When you have replicates, you can have the confidence intervals. So you have a shadow outside of this line, and the size of this shadow is demonstrating how good or how bad is your experiment. Okay, guys, so where can we see how good or how bad were our experiment? You can know here, regression reports, the summary fit with the R-square and R-square adjusted, and the ANOVA analysis. So the analysis of variance when you compare the variation caused by your model against the variation caused by your errors, and you can see how good or how bad was your experiment. So the prediction profiler that we have here, they have this little shadow, okay? You can turn off this as well. If you don't like to show this, you can just turn off, but it's exactly the same situation where this equation here, this interaction situation here, this animation here is based on your prediction expression that is based on your estimates result that you saw in the graphical analysis. So this is how we run quantitative analysis in our DOEs, and the next step is how to reduce this model. Okay, it's very important to reduce the model, and let's see in the next video some risks, some details that we should consider. Bye bye, see you the next one.